Hello and welcome. In this video I'm going to complete a series of tasks for segment routing on OcNOS devices. The task is as follows. First of all, let's take a look at the task, and then I'm going to explain everything in the topology and what we are about to do. The task says enable segment routing traffic engineer. Define a simple SRT policy. By simple it means that we are not going to add any specific criteria other than very minor things. And here it says the type should be dynamic, and this is going to consider fewer hop counts as the metric to the destination. And we are going to assess it on ABC's loopbacks. So first of all, I'm going to stop Alex because we don't have anything about Alex anymore to do here, and I'm going to just close these here, and then I'm going to start ABC rather, and while they are coming up, I'm going to explain what we are going to do in this task. Now basically, we have enabled segment routing in our network. With that, we have full control over the path to the destination, which means that we are kind of doing source routing in here. Now, the task says that I'm going to use a dynamic type of segment routing, which means that I'm going to just receive the information from some other maybe source. Let's say in my case, for example, IS is going to be the source of the information to get to the destination. I'm not going to decide where the packet goes. I'm going to receive the information from here. And with this, I'm going to choose the smaller number of hop counts to the destination as the best path. So if I just check my topology here, you can see that from router 3, which is my ingress PE, to router 6, which is my egress PE, I have multiple paths. This one, for example, takes 2 hops to get to destination. This one takes 2 hops to get to destination. The other one, which I'm going to mark it as blue, has 3 hops. This one, for example, has 3 hops. This one has 3 hops, and I can even go with more hop number. Let's say, for example, I'm choosing this red line, which goes 1, 2, 3, 4, 5 hops to the destination. So which one of them is going to be preferred? These two, which are the lowest number of hop counts, they are going to be preferred in our policy here. So let's do this configuration and see what we are going to do. Most of the configuration, of course, is going to be done on router 3 and a little bit on router 6. On router 6, what I'm going to do is to define VRF for ABC, which I have done it, of course, before, and I'm just going to show you the configuration. And I'm going to paste that configuration into router 3, but the rest of the configuration for segment routing is going to be done on router 3. So let's go to router 6 first of all. On router 6, I'm going to say enable, show, run, and I'm just going to show you all the configuration. Here you can see that I have VRF defined. In this VRF, I have just chosen to have route distinguisher as 300 300 and route target for import and export as 300 300. I'm going to select this, and I'm going to go to router 3, and I'm pasting this configuration here and committing it. So this is the first one. On router 6, if I just go down a little bit, you can see that I have this interface under ABC VRF Ethernet 07. The same interface, of course, in router 3 is connected to router 9 on IVPC. So I'm going to just put that under VRF. So on router 3, what I need to do is to say interface ETH7, and then I'm going to say do show run interface ETH7, and you can see that there is no configuration under that. The first line of configuration is going to be IP VRF forwarding, and that's going to be ABC, and the next piece of configuration is going to be an IP address assignment. So I'm going to say IP address is going to be 10.393/24, and then I'm going to commit this part of the configuration. So now if I just say show run interface ETH7, you can see that I have applied a VRF under ABC for this interface. Now, next piece of configuration, if I go down, which is very important, is going to be the BGP configuration. So if I just go to ABC on the left, which is router 9, I'm going to open this, and also router 10, of course. You can see that on router 9 I have already defined some stuff. Let me show you. I go to here to show all the running configurations so that you can see what we have. One of them is the interface which connects to router 3, which is configured with the IP address, of course, in the same subnet, 10.3.9. Then if I just go down, you can see that I have this router BGP configured, and my neighbor is going to be 10.3.9.3, remote AS is going to be 100, which means that I have configured router 9 to be a neighbor to router 3. And under this, what I have done is I have advertised 9999 into my routing table. That's all. And of course, loopback interface is configured with this 9999. This means that IPBGP is going to be advertising this to the other side. Okay, let's go to router 3 and do the same thing here. And what I'm going to do is to say router BGP 100. And under this, I'm going to say address family IPv4, but for VRF ABC. Then I'm going to say my neighbor is going to be 10.3.9.9, which is in remote AS. Remote AS 300. If I just check router 9, you can see that BGP is configured in remote AS 300. The other branch on the right is 301. So if I just go to here and log into router 10 and say en show run, you can see that I have 301 on the other side. So going back to router 3, I have this neighbor. I'm going to activate this neighbor here and commit the configuration. Okay, so far there is nothing very important. So if I just say do show IPBGP VP and V4 all unicasts, this is going to not unicast all only, and not all, of course, all summary. All summary. You can see that I have an adjacency with 10.3.9.9, which is established. Let me just say something. Terminal width is 256, and now I'm going to say this command should be executed. So if I just go to configuration mode, that would be easier to reach to this command. So you can see that I have an adjacency with 6666, which is the other P on the right. And I have this adjacency of 10.3.9.9, which I just configured, and I'm receiving the prefixes from the other side. And the prefix, of course, is this one. The one that I have just checked it. Up here, you can see that I am receiving one prefix. And where was that? Up here, yes. So the one prefix that I am receiving from the other side is just 9999, and I am also receiving 10.10.10.10 from the other side. So 9999 did not appear here because at that time I had not received it. Now if I just execute this command one more time, you can see that 9999 is also here, and I can see that. So this part is done as well, but let's get to traffic engineering part. And first of all, let me just see if I have connectivity. On router 9, I'm going to check the connectivity, ping 10, 10, 10, 10. I'm going to source it from 9999. The ping goes through without any trouble. Okay, so what we have here is a virtualized environment. In case you saw that the ping doesn't go through, although the configuration is correct, all you need to do is to just reload these devices. Maybe the buffer is overloaded, or some other problem is stopping this virtualization from working correctly. On my system, of course, all I need to do sometimes, of course, is just to reload the router using reload command. Now going back to router 3, I'm going to start the configuration of segment routing. So let's go with segment routing. Under that, we are going to have traffic engineering. This is one of the options that we have, and the other one which might be important is going to be this mapping server. For now, I'm going to use traffic engineering. and after that hit enter. Under this we can define policy. Also we can have segment lists for explicit segment lists, which I'm going to do in another video. And also on-demand next hop, which is what we call it ODN. We are going to do this in another video as a matter of fact. So the policy that I'm using here, it can have a name or number as a name, doesn't really matter. I'm going to say this is called a dynamic TE, and after that hit enter. Under this there are some specific things that we are going to decide to use, and what I'm trying to say is I'm just using a candidate path which is going to select whatever ISIS says, and ISIS by default is going to choose the shortest path to destination based on hop count. So I'm going to use this one, but before that I'm going to use color, and color of course doesn't have anything to do with what we call it affinity here, because in there we have some colors for different links. As a matter of fact, those are just names, they are not very important, but you can just say that, for example, I have some fiber links between my routers, so I'm going to name them fiber, or name them red or blue or black or whatever that you want to name it. And later we can say that, okay, this kind of traffic that I am sending should go through that red links, which are in this case, for example, fiber links. Or you can just decide some other criteria for sending your traffic to destination. Based on that, you can just color your links with a bit value that is in here we call it affinity. What I mean by color here is a specific policy which I'm going to apply maybe to a VRF or to every VRF that we have here. So if I just specify this under VRF, then this is going to be VRF specific. If I don't, that is going to be a global configuration. So let's go through here. I'm going to say color is going to be just a number, so I can just put a number here, 1, and the destination is going to be 6666, which is the other PE that I have there. And after that, color 1, it should say endpoint, of course. Color 1, yes, endpoint is going to be 6666, and after that hit enter. And I'm going to say the candidate path is going to be selected. There is a value for that. Let's say candidate path 1. And under this, I can decide what kind of a candidate path I'm trying to use. I'm not using any constraints. If I have a PC server, then constraints would be good. But like I said, I'm going to speak about this in another video. But let's see what we have here. So under constraints, if I hit enter, you can see that I can select metric type, or I can just say for a specific IP address or IPv6 address, which is which belongs to one of these routers, I'm going to use a loose or strict, type of destination. So affinity is another one, which I'm not going to configure it right now. But what I'm trying to say is metric type. And if I just go with metric type, you can see that it says metric type could be configured as IGP or latency or TE. Let's say that I'm going to say metric type is IGP and hit enter. If I try to commit this, I'm going to receive this error that says the type of constraint that you define depends on segment routing traffic engineering policy dynamics. This is what I have created, but it says that you cannot really have this here because you have not configured any dynamic path right now. So I'm gonna say show transaction current, and I'm just going to remove this constraints here. Okay, so I just go under segment routing traffic engineering. Under here I'm going to say no constraints. Okay, now I'm committing this, no problem. So a candidate path can have a preference. If I have multiple candidate path, then based on preference, they are going to be decided. If both of them have the same preference, then or multiple of them, of course, have the same preference, then I'm going to load balance between different paths that I have created. And segment routing by default has ECMP enabled, so you don't have to do anything more than just configuring preference and just make sure that the preference for different paths are the same. Because I'm just defining one path, I don't need to configure preference, but you can just say, okay, I'm going to say with preference of 100. By default, preference is going to be set to 100. I can just increase this or decrease this. I'm okay with this value. Next, I'm going to say dynamic path. And for dynamic path, I can say, okay, I'm using ISIS, or I'm using OSPF, or PCEP. Now, ISIS is the protocol that I have used in my network. OSPF, you can have it in your network. PCEP, or Path Calculation Element Protocol. That is going to be, let's say that there is a server in your network which is going to do path calculation for you. In my case, of course, I'm just deciding that this local router is going to do that, but if you configure a PCE server in your network, then you are going to receive the calculation information from that server, which means that some of the loads from our PE is going to be taken out. So we are not going to have so much pressure on this PE. But in this case, of course, I'm going to use ISIS, and the process name is OE, and after that hit enter. So that is going to decide how we are going to get to the destination. And you know that ISIS has by default a metric of 10 for each one of the links. So you're going to have this as the best path to destination. So if I just say commit, my configuration is done. What if I have constraints here? One more time, if I just go under constraints and then say metric type, you can see that, and just let me just show you what it says for metric type. It just said metric type, nothing more than that. So if I just say metric type, after that I can select IGP, and here I can say enter. Now if I just commit this configuration again, I'm going to receive this error that says, okay, you're trying to do something that is not supposed to be when you just select dynamic ISIS. Here it says that what you have done is applicable only for PCEP candidate paths, like I said, so you don't have so much resilience in this case. So I'm going to just say abort transaction for the last commands that I have. If I say show run segment routing and hit enter, you can see that this is my final configuration. I am not applying this to any VRF for now. I'm going to show you in a second how we can do that. And before that, I'm going to just go to router 9 and issue the ping one more time. You can see that the ping is going on. If I go back to router 3, the ping is going on for itself. We don't have to do anything for that. I'm going to say show MPLS segment routing. So segment routing. So show segment routing, and I can just go with policy, and after that detail, which is going to give me more information about the policy that we have. Right now you can see that it says the admin status is up, the operation status is up. This one is very important. The tunnel is 6666 and the color is 1, exactly what we just did. The name of the policy is dynamic TE. Now going down, you can see some information about CSPF. It says that the limit is going to be 100 times, and each one of these retries are going to happen in 10 seconds. So in case after 1000 seconds CSPF could not calculate a path to the destination, it's going to give up. And going down, you can see that it says candidate path ID is active, preference is 100, and this is selected based on ISIS. And nothing more than that. And of course, some information about out interface, which is Ethernet 1, which means that this is going to send the traffic to router 1. The reason for that is if I go to router 1, from there I can go directly to router 6 based on the metric. I'm going to change this in a second, but you can just see what we have done. A metric type, of course, is called traffic engineer. So that is by default selected for us. Okay, so if I just go to R3 and try to capture Ethernet 1, now you can see that the pings are going through here. If I select one of these packets, for example, I'm going to just increase here. You can see that the labels are inserted on top. We are sending this to router 6 as a destination. And before that, we are inserting a label, which is an adjacency label, which goes to router 1. So it takes us to router 1 and from there to router 6. What happens if I suspend this link? So if I just right click on this link and say suspend, or I need to unlike this for some reason, or maybe I can just do it by shutting down Ethernet 1 on router 3, and I'm going to see what is going to happen. So if I just go to here and go to interface ETH1 and say shut and commit this configuration, if I go back to here, you can see that the ping is still going on without any problem. So going back to here, you can see that now I have no traffic in here, but the traffic should go to Ethernet 2 because this is going to be taken to router 2 and from there to router 6 in 2 hops. So if I just say capture ETH2 and wait for this to come up, now you can see that the pings are going through that and not other links. So this means that in case of a problem, I can just change the labels. Let's go back to here and select one of these. You can see that I can just change the labels and just send it to the destination through another link. So that is how you configure dynamic type of traffic engineering. Let me show you some more commands here which are going to be important for us. Show MPLS VRF table is going to be another verification command which is important, and specifically you can just see that color is specified here, the color that we are using, which is number 1. There is no tunnel policy applied because, like I said, I have not applied it to any specific VRF here. I'm going to show you how we can do it in a second, but right now we have not done anything about that, and this is going to be applied to every traffic that goes through our network. And also the specific prefix that we are talking about is 10.10.10.10. Now let me show you something. If I just go to configuration mode and I'm going to say a tunnel policy, and I'm just calling this tunnel policy dynamic TE tunnel. If I just create this and under this say that I am using color number 1 and hit enter, and I'm going to say tunnel type is going to be SRMPLS and hit enter, and then I assign this tunnel to the VRF. So if I just say IP VRF ABC, under this I can just say tunnel select policy and then specify this tunnel that I just created here to there. So dynamic tunnel is going to be this, and hit enter. Then I'm going to say commit. I'm going to show you the configuration that we have here. So show running configuration of tunnel policy. This is the tunnel policy that I created. And show running configuration of VRF ABC. So I just attached this tunnel policy to here. Now I'm going to save the configuration. If I go back to router 9 and try the ping again, the ping is going through without any problem. And I'm just going to stop this. Going back to router 3, I'm going to say show MPLS VRF table. So show MPLS VRF table. Now you can see that the tunnel policy has changed to what we just created here as tunnel policy. So this is how we just configure a tunnel and attach it to a VRF. This means that the policy that we just created is specifically for a VRF and not for everybody. Okay, so with this, we are going to finish this video. I hope this has been informative for you, and see you in next videos.